What if the biggest barrier to innovation isn't cost or technology, but knowing what's possible? Welcome to Industry Ignited, the podcast where we spotlight the innovators and entrepreneurs turning ideas into real world impact. I'm your host, Dr. Leeanne Aguilar, and today I'm joined by Matthew Guy, CEO of Niche 3D. Matt is an entrepreneur, mechanical engineer, and additive manufacturing expert who helps companies turn ideas into functional products using 3D printing. Matt, welcome to Industry Ignited.
Thanks for having me on, Leanne. I'm excited to share my journey and expose your audience to the world of 3D printing.
Yeah, I'm really excited to learn more about 3D printing. I know you've said, like growing up to getting started, you built Legos and took things apart. How did that curiosity with Legos shape your path into mechanical engineering?
Yeah, I think, just the curiosity of learning how things work. My favorite subject in school was always science. So it was learning how things worked, and then engineering was kind of the thing of how to apply that science and use what you learned to, make new things. And I also just love hands-on work. So I think the mixture of those two things kind of led to me going more into like mechanical engineering.
Yeah, just kind of set the path. So the
Yeah.
curiosity in combination with just the hands-on, being able to create things and solve problems at the same time. That makes sense. So you originally thought robotics though might be your future. What pulled you into 3D printing instead?
Yeah, I did robotics throughout middle school and high school, so I was really big into it. I loved the mix of the disciplines, engineering disciplines like mechanical engineering, electrical, and programming. And I went to UMass Lowell for mechanical engineering. You could do a minor in robotics. Sadly, I couldn't quite fit it into my schedule and graduate in 4 years. So I kind of didn't do the minor. And college is always so busy. I couldn't fit in everything you'd want to do. But then when I graduated with my mechanical engineering degree, back then there wasn't as many robotics places in the area as I live around Boston as there is now. And a lot of them at the time wanted like PhDs in robotics. There wasn't as many jobs just for mechanical engineers at these robotics companies. So I worked at a few other mechanical engineering companies. And then with my money, I bought a 3D printer and got into that. And that's very similar to robotics, where it's a mixture of the engineering disciplines. So I got really into that, and it was kind of replaced my robotics interest. I still love robotics, but it slid in to replace that life goal or career goal.
Okay. Yeah, that makes sense. So, like after graduating, you just found that there weren't as many job opportunities, is what I'm hearing, in robotics in your area.
Yeah, and they were hard to
And
get into. And you needed more of a degree that I didn't have yet and stuff like that.
yeah, that makes sense. But then you discovered 3D printing. And
Yeah.
from what I understand, before you started your own company, you worked at multiple other 3D startups.
Yes.
What lessons, good or bad, did you take from those experiences with other companies?
I learned that selling the technology and the material is extremely hard. You're trying to break into a manufacturing industry that's been around for ages, and it's hard to change how people manufacture parts and what technology they use and how they build out and design parts. So I found out very quickly that you have to focus on applications, not just strictly the materials and technologies. Without proven applications, the customers have no reason to buy the printers or materials. And the main reason why I started Niche 3D was to focus on the applications, because I saw a lot of being at these different startups and seeing other startups too. Not all of them were focusing on applications. So they had really cool technologies and materials, but they were having a really hard time finding customers or finding fits for their applications. There's so many different things being made. And some of it's like you almost don't know what people make or what's out there or what people need without already being at these companies or industries. So it's really hard. You're building something for a puzzle. You're building a puzzle piece for a puzzle, but then you don't actually know how a lot of these companies don't um, deliver it in an effect where they know how the puzzle is going to fit in yet. They're
Mm.
just like, oh, this technology and material is interesting. Let's see where we can go down with this. But they're not always looking ahead of how is this going to be utilized, who's going to use this, and let's make sure we build towards that.
Right. Yeah, and I even see that happening with AI these days as well. It's like they see this
Absolutely.
cool new technology and it's like, oh, well, how can we make this work without really having an application yet? They're kind of trying to
Yeah.
backwards,
And they're
create
very, very
something.
similar because 3D
Uh-huh.
printing, it's very general. You can, it's a general manufacturing machine. So you can make all kinds of stuff. Same with AI. It's very general. You can use it for all kinds of stuff. So it's like, okay, where does it actually fit in and work really, really, really well?
Right. Yeah, that makes sense. So many people still see 3D printing as a hobby or novelty. How do you explain its real business value to clients?
So that's hard. It's come with approach of I want to talk and ask questions with my clients because there's so many different things that add value from 3D printing, but you don't know what the value your customers need. So I like to investigate and talk with them first because, additive manufacturing, 3D printing is just an umbrella of technologies and materials. And it's not like one thing. So different technologies, different materials can provide different things and add different value. So it's better to understand what the customer needs and then figure out where in the additive manufacturing space fits for what they need for technology and material that adds values that they need. Could be any cheaper costs. I need to be able to make more complex parts. I need certain materials. I need to fit this standard or that standard. And not all the 3D printing technologies might fit for that. You got to be selective and you got to figure out your client needs so then you can guide them towards the right direction and actually give them the value instead of a lot of these printers, again, we'll go with some people don't know what their application is for their printer technology. So, they say the value of this printer is this and this and this. But in reality, some people don't want that or care about that. And it's not really value add because they're
Right.
not focusing on the application or the industry or something. So I really like to narrow it down and be selective because one value for one company is not going to be a valuable thing for another company.
Yeah, that makes sense too. So it's really getting to know your customers' needs on an individual level, like really
Yeah.
understanding what their problems are, what they're struggling with, and then that will help you understand how it can be, applied in,
Yep.
solving their specific
Or,
scenario.
sometimes I'll be like, 3D printing is actually not the solution.
Mm,
Maybe we can use it on the way to get to the real solution you need. But I don't try to sell it as the fit for everything.
yeah. So you're approaching it more from the mechanical engineering side, is what I'm hearing then.
Yeah,
And so the 3D printing is more of a tool that you're
absolutely.
using, but it's not always the answer.
It's not always the answer. Yeah.
Okay. Now, I know you work closely with pharmaceutical and medical companies. What problems are they solving with 3D printing that perhaps traditional manufacturing struggles with?
I'm doing a lot of custom solutions at low volumes. So if not everyone in the market needs a part like this, so it's very, very custom to their workflows. So if they were to do this traditionally manufactured way, it wouldn't be cost effective because they don't need that high volume. Or the same materials might not be there. Or, some of the geometries I'm printing for these customers are more complex or whatever. Um, and I can make quicker iterations of the designs that most of the stuff I am finding a solution for them.
Hmm.
So I'm going through their full product development phase and saying, okay, this is what you need. I design the part, we do a prototype, I send it out to them, they test it, they're like, this is perfect. I print 100 of them in the correct material or whatever, and they get the parts pretty quickly. I'm making custom solutions for them, and I can make quick iterations. If they need a quick update or they're changing this or that size, it's cheap, it's easy, and they don't have to wait and get it injection molded and get charged a lot for tooling and all that stuff. So I can make custom applications for them very quickly and also manufacture in low production quantities, so like hundreds to thousands for them.
Hmm. Okay. And so it's a lot more cost effective and
Yeah.
quicker.
And
And yeah.
and they don't have to buy usually when you're doing products, you're doing injection molding, and to make it worth it, you need to buy thousands to hundreds of thousands to millions of parts.
Hmm.
But this is mostly low production and they don't have to keep an inventory. If they need 5, I can print 5. If they need 1,000, I can print 1,000. So there's really no minimum order quantity like with traditional manufacturing.
Yeah, that makes sense. And you emphasize custom tuning and process optimization instead of one size fits all printing.
Yeah.
Why does that matter so much for production quality parts?
Yeah, it comes down to a few things. Most of my parts are in the healthcare industry, medical, pharmaceutical. So I really want to make sure they hold up well and a long time in the field. So I might over engineer them, and I might print them in a very specific way to make it sure they're really strong. Some of the parts I'm printing a little more complex and actually push some of the boundary limits of what 3D printing can do. So I really have like thin walls, very small features. So I got to really tune it so that all the parts come out really well, reliable. I can print hundreds to thousands of these parts without a lot of headaches and repeatably. And then also making sure the post-processing time. Some people might think you print a part and it just comes off your printer and it's done. That's not always true. Some parts need support material to support overhangs. So once the part comes off the printer, I still got to, do some QA, QC, and also pull off all the supports and clean off anything. So I'm trying to make it as easy to take off the supports, but also leave a nice undersurface so that, when I'm processing 1,000 parts, it doesn't take me forever, trying to either pull them off or if it made a defect, fixing the defect. So it comes a lot into, I always like to say I print one way for rapid prototyping. We just need it quick. We just need to see if it fits and functions properly.
Right.
But then when we move the part from prototyping to production, I'll go in again and change it so that I can make sure I can print, maybe 5 to hundreds of parts in one build bed at the same time without failures and with easy post-processing.
Yeah. How big are the parts that you're manufacturing?
Let's see. I don't think I brought any super big parts. Oh, actually, I guess this one's big. So, I mean, most of my parts are, I'd say, oh, come on, fits in the palm of your hand. But I can print parts like pretty big. So I have several different printers that print anywhere from like 360 cubed millimeters to I think 420 cubed millimeters. So that's about 12 to 14 inches.
Okay.
But I'd say most of the stuff I'm printing can fit in the palm of your hand, or so like this is the build plate of one of the printers I use for production the most. So this is roughly the size of the builds I do, or I put a lot of the same parts on one plate.
Okay. So a little bigger than a piece of paper, let's say.
Yeah.
Yeah. Okay. And how many parts can you print an hour?
Yeah. So that question gets kind of difficult. It comes down to a lot of things. It comes down to the material. Different materials I can print at different speeds. So some of the cheaper PLA materials I can print extremely fast, but then some of the more engineering grade materials I might have to print slower. It's just the restrictions on how the materials act. It depends how many. It comes down a lot to process. How much infill, how much am I filling up the part with material, what my layer height is. So, when you're printing in layers.
Mm-hmm.
So usually the standard layer height's 0.2 millimeters. But if I'm printing something that's smaller, I might want to do a smaller layer height. So that drastically increases print time. So if I'm doing multicolor, that drastically increases. It can vary greatly. Something like this part is I printed there's some third-party parts on this, but it gets printed like this on the bed. And I think this takes about an hour or 40 minutes.
Mm-hmm.
But I'll usually print like 10 on a bed or so. But yeah, it's not a straightforward answer, sadly. And it really depends on what the customer needs and how big the parts are. I'd say the biggest determining factor is how tall the part is.
Okay. All right. And yes, and the part that you were holding there is what, about 3 inches or so in size, or?
Yeah, about 3 inches.
Mm-hmm. Okay. But they print multiple at a time, like you said, about 10 at a
Yeah, so I'll
time.
print several on the print bed at the same time.
And what types of materials are you using when you're printing?
All kinds. So do I have any? Yeah, so like one of the cheaper materials is just PLA. It's nothing fancy. That goes for about anywhere from $10 to like $20 a spool. To go one step further, it's a little better. I use PETG, so that's a little bit more ductile. It's not as brittle as PLA. So I'd say it's a little bit more almost of an engineering grade type material. Not quite, but it's much better for more heavy use parts. I'd say my biggest material I print with is actually this white material, which is Rhizzium glass fiber. So it's a special blend of polymers with chopped glass fiber in it. So it's very, very small chopped pieces of glass fiber in it. My pharmaceutical customers love this material. It's great in cold temperature storage. It's chemical resistant. So I used to work at the startup that produced this, Rise, and they went out of business. But the CEO bought all the IP, so I still work with him and I actually sell this material on my website too. So
Okay.
not only do I this is why I love about doing it is, I'm not just selling material. This is one of my biggest materials I use in-house.
Hmm.
So I'm a true and tested user of the material.
Did you develop the material, or is it something that was already pre-existing that you're just using?
Yeah, when I got to Rise, it was pretty much already developed, but I helped develop a lot of the print profiles for their machines. So, figuring out how to print in the machine and the best settings. And when I was there, I was also handling a lot of the actual manufacturing of it. So I was working with our third party companies to the filament produced.
Okay. So walk me through the process a little bit. Because I know you have to create the design as well.
Yes.
How does it work?
So usually a customer coming to me with I have a problem, I have an idea for a solution. So then I'll use a CAD program, which is just computer aided drafting, so a 3D modeling system. I usually use SolidWorks. I'll design a part in that. And then while I'm designing, not only am I meeting, their specs and criteria to fit their solution, but I'm also doing something called DFAM, so design for additive manufacturing. So I'm thinking about how the part, what orientation of the plate is it going to be printed? What material am I going to use? So I'm designing for the process. You'll see with any other type of manufacturing, like injection molding, CNC, you have to make sure you're designing for the process so you can actually produce the part and the part comes out well. So that's in the back of my head and in the forefront when I'm designing. And then when the part's designed, I'll export it as like an STL or a mesh or a step file, basically just a 3D model I can bring into what we call a slicer. So a slicer is a program that you put in all your process parameters and settings. And so the 3D printers are, I'm going to put it this way, kind of stupid. They're not very smart. They don't use a lot of sensors. They're kind of just taking instructions. So, it's
Mm.
almost like a step-by-step instructions, you're gonna move here, you're gonna move there. So the slicer basically takes a 3D model, takes the settings and processes that you give it, it will cut up the model into slices, and then it breaks down. So every slice will have, it'll extrude and it'll create movement for the print head to where to deposit material. And it'll spit out what we call a G code, which is just that set of instructions. So it's not like, some of your robotics now have a lot of sensors and they're smart, like, oh, yeah, I know this is a pen and it'll pick it up or whatever. This is just following like step by step instructions.
Hmm.
So the slicer spits out that code that I can then either put on a flash card or send directly to the printer from my computer over Wi Fi. And the printer will just follow those step by step instructions in an hour, 2 hours, or maybe 24 hours, depending on what you're doing.
Okay.
Your part will be done.
Awesome. Now, are you creating designs for other people as well who might have the actual printers? Do you do that as
Um,
well, or are you creating all of your parts yourself?
Most of the stuff I'm designing for my customers and then print for my customers. There's a few circumstances I've designed, because it's the technology is catching on. So some people do have some of the cheaper or even high end printers in their offices now and don't have engineers or designers to help them actually make stuff that they need. So I
Right.
do sometimes just design and then send out the part and then they'll print it in house. So I do
Yeah.
that sometimes, but I'd say the majority of my business is the full consulting and, design to I print tons of
Turnkey,
parts.
yeah,
Yeah.
process. Okay. Now, what's an example of a project where 3D printing significantly improved speed, cost, or performance for a client?
Yeah. So I got some show on top of this one. So this is one of my assistive medical device companies. It's a small startup company He designs products for people either with spinal problems or they don't have a lot of strength in their hands and arms. So basically, they don't have a lot of grip, or they can't really use their fingers that much, or not a lot of dexterity. So they can't do a lot of stuff for themselves. So this is kind of a device. Let's see if I can get it all in frame, where you strap this onto your hand, and then it's almost like a quick tool changer. So you can pick up your fork, you can eat with it, you can pick up your cell phone and use your cell phone. But it's, all these are parts are 3D printed.
Mm-hmm.
He's got about, I think, 10 different parts. So if you're a startup company and you needed 10 different SKUs manufactured, traditionally you'd have to go, you try to go overseas and you'd get this injection molded, and the upfront cost could be up to $100,000, right? Just to get the parts made. Or not even to get the part made, to get the tooling made to then be able to manufacture the parts.
Oh, wow.
So the upfront cost is just ridiculously high. But with 3D printing, I'd say there's almost no upfront cost. So he's able to bring this device to market without having to get capital or take on loans. So, all the parts are printed right now. Maybe later he'll transition to injection molding once he gets sales up and the quantities make sense. But, something years ago you'd have to have capital for to start the company and start selling. Now he doesn't need any upfront cost. He orders whatever he needs. I can provide a low enough price that makes sense for him. And it's still something in development. So whenever he gets feedback from customers or wants something changed, we can do rapid iterations. And then, next day, if he needs a set, we can just start producing them. You don't have to wait for tooling and pay an extra $10,000 to get tooling made.
Right.
So it's something, his company wouldn't be where it is right now if he couldn't produce these parts by 3D printing. The complexity of the parts too is currently in a state where you can't injection mold it or make it traditionally because of different cavities and stuff, where they actually have to be redesigned, and maybe one or two parts to even produce them.
Yeah, that makes sense. What's the kind of cutoff from the 3D printer to injection molding?
Yeah,
Let's say.
There is a more elaborate answer to this because it will depend on technology and materials, but we'll just do plastics, for example. There's also obviously different technologies within plastics. So there's like what I'm usually doing is called FDM or FFF. So it's just like a hot glue gun. Think of it like a hot glue gun that's just outputting, that has a nozzle and it's just outputting material. Then there's other ones that use powder processing. So I'll put powder down, either hit it with inkjet to bind together or just laser sinter it together. Those are a little bit better for mass production of parts if it can print the material you need. But I'd say, 3D printing, just to give a straightforward answer, is probably, 0 to maybe 10,000 parts. Or maybe even, I think, depending on the technology, you could even get to 100,000 parts. It really depends on how complex the part is, how big the part is, what materials you use, and if you have the money to buy, if you have to buy 100,000 at a time or 1 million at a time, that's when I'd say you'd probably switch to injection molding. It makes sense economically.
Yeah, okay. Now you work with a wide range of materials also, from plastics to specialized lab-grade filaments.
Yep.
How do materials unlock new applications?
It's very interesting because a lot of people don't always think about it, but every material acts completely differently and a bunch of different properties. So like think about chemical resistances, impact resistance, tensile strength, rigidity. A lot of the printing materials we use absorb a lot of moisture, so that can affect how it acts in different applications. So sometimes you don't want a material that absorbs a lot of moisture or has chemical resistances. And then, like you can even do metal. The end part you get is not always going to be true or comparable to its injection molded or traditionally manufactured part. We don't always hit the same strengths, or sometimes we hit more strengths depending on the process. But you have to think about the technology mixed with the material, with how the part's going to come out in terms of the properties. Especially like, we're printing with layers. So usually we'll say, the material might be food safe, but the printed part might not be food safe because you've got all these little micro crevices and bacteria can get under there and it's hard to clean. But there's different, you can do different post processing to get it to that food safe level or use a different technology. But yeah, so I'm going to take this back to, how I kind of started the company was printing parts like this. So they were originally getting parts printed in PLA, which is brittle. It's a cheaper material. It doesn't hold up well in the cold. It absorbs moisture and stuff like that. And they were putting these parts in freezers, deep freezers, like negative 80 degrees Celsius. And the parts would, they'd take them out of the freezer and they'd just break.
Yeah.
So
Shatter.
yeah, they just shatter. So, you have to think about material selection. Like this material does not absorb moisture. So, when you take it out of the freezer, it might collect condensation and absorb that, and then you put it back in the freezer. The water in it might expand and slowly break it down over time. This material is actually super strong in freezers, so it holds up really well, and it holds dimensional stability. So there's like a laundry list of all different types of properties that materials give, and it's not only knowing what the materials can do, but what the limitations of 3D printing too. Because it's not, like I said, you might get one properties in injection molding, but if you use the material in the 3D printing process, you would get a whole different types of properties.
Okay. Oh, that makes sense. So even though it's the same shape and the same material, the two different processes would output different results just because
Yep.
of the process.
Mm-hmm.
And okay. Now, when you're designing or building parts, can the 3D printer create layers out of different materials? Or are you using different materials in the same part?
Yes. So sometimes I am. I have one printer that can do that really well right now. So I wish I had a part I just printed. So some people will use it. So like I said before, sometimes you're printing support material. So like if I printed this part like this flat on the bed, you'd have to support this or else the material would just droop and go nowhere. So you'd have to put support material underneath it. So you can actually use a different material for the support material and have this material sit directly on it. Usually when you're printing support, you leave a little gap so you can remove it easily. But if you have a different material that doesn't stick 100% to the material, you can print directly on top of it and have really, really smooth surfaces. So a lot of people use that. And then sometimes more of the mixing. So I like experimenting with these multi-material prints where you're mixing, hard, rigid materials with the soft, flexible material. That's really cool to start getting into and experimenting with. I just printed, because there's this new material on the market called PIBA, which is a soft, flexible material and has a lot of rebound. So it bounces well. My old CEO had made some golf balls out of this. Actually, I remember testing some for him. So I looked up, I wonder, because, if people don't know, in a golf ball, it's not just one material. There's the outer material, and then there's sometimes multiple materials for the core. And actually, one of the materials they use is this PIBA material. So I'm like, oh, this can kind of be a cool print. I'll do the outside in this Rhizome glass fiber, and then I'll actually print a core in this PIBA material. So it's more similar to how a golf ball is actually made. I haven't tested it out yet, but yeah, you can start getting to this realm where you're mixing materials and you're getting parts that you couldn't really manufacture like this before. And it gets really, really interesting.
Yeah. So why do you think 3D printing is still underutilized despite being around for decades and having advantages such as cost and flexibility, like you're mentioning?
It has been around for decades. You have to think that it's not just technology, it's part of the manufacturing market. And the manufacturing has been around for much longer. So it's still a relatively new technology in terms of manufacturing. You have to design for it differently. You have to manufacture with it differently. Some of the bridging that gap between the knowledge and people understanding what it can do. People still see like people are just printing all these silly little fidget toys or little toys and stuff like that. They think it's just a silly gimmick or can't really produce good parts unless you have one of those $100,000 machines or extremely
Hmm.
expensive machines, even millions of dollars. Some of the printers are very expensive. But so we're still pushing back against this like knowledge gap and perception of the technology. So I think it's harder for people to get into it, especially like some of the companies now are buying these cheaper printers, but there's still a knowledge gap to be able to, okay, how to actually utilize the technology properly and get
Yeah.
really, really good results from it. They still don't have that in house always. So that's why it's, a lot of companies like me or some of my other friends that are running their own startups are helping bridge that gap because a lot of people just know traditional manufacturing and 3D printing is different.
Hmm. Right. Yeah. So I think you do need someone like you who is an engineer who knows how to design the product, and then not only that, but create the design
Print
and
profiles.
print profile. Thank you for
Yep.
actually creating it with the 3D printer as well. Now, can you explain, like in a nutshell, for those who aren't familiar with additive manufacturing, like what is it exactly?
Oh, that's a good question. It's okay. So I'm gonna blanket most of traditional manufacturing as subtractive manufacturing. So you got a block of material and you're milling away, you're removing material to get to your part. So that's a lot of your CNC or woodworking and stuff like that. While additive manufacturing, you're building up the parts, you're adding material to get to your
Mm,
part.
okay.
I think that's kind of the simplest way to say it. And a lot of it is um, building up layer by layer by layer.
Okay. So is injective molding also additive manufacturing? Injection
No, it's
molding?
not really. I guess not quite. It's more of a, I'd say, instantaneous process because you're just loading a mold with hot plastic very quickly. So it's not seen as additive manufacturing at all in the market, but it's not. It's also not subtractive manufacturing, right? So it's somewhere in between, I guess you could say.
Oh, okay. All right. So other than 3D printing, what else would qualify as additive manufacturing?
It's really anything 3D printing. It's all under the same umbrella. There's nothing really outside of that that would be considered additive, I'd say. So here's a circumstance that's kind of interesting. Sometimes we'll use additive to make the tools for these other manufacturing. So like sand castable molds. Sometimes to do cast metal for like engine blocks or something, you make a mold first and then you pour the metal in. But we're actually printing with sand now to make these giant sand cast molds for the metal. So we're actually using additive manufacturing to then use an injection molding process or a metal molding casting process. So it's actually kind of a mix. You're using one to do the other.
Okay. Yeah. Now, how is AI starting to influence additive manufacturing, and where do you see its real impact today versus hype?
Yeah, I think, like you said earlier, AI is still kind of small, still finding its applications. Right now, there's a bunch of people trying to do AI 3D modeling. So you give it your prompt, just like you talk with ChatGPT, and it would spit out a 3D model. It's okay. I'd say it's probably better geared for like assets for video games or stuff like that. Right now they're not thinking of this how the part's going to be manufactured to make sure it's actually manufacturable. And then at least I've found and my friends have found with a lot of them, it's almost it's you can't really iterate. So once you give it a prompt and it gives you a model, then you ask to change the model. It doesn't really change it. It more like starts from scratch. So you can't really iterate and make changes really, really well. So I don't, at least in the modeling side, I it's not there yet at all for me. I
Mm,
don't really use it for that, especially on the engineering side. It's not going to be able to give what I need for engineering. For more, I'm gonna call it organic or artsy stuff,
uh-huh.
it can get there. But if the first result is not what you want it to be, it's going to be hard to get it to exactly what you want and make those changes. What I'm Then other people are using AI for figuring out material innovation. Some people are starting to do it for slicing, so you can slice it easier without having to change the settings, and the AI just does it itself. The only, I'd say, real AIs that I use day to day for 3D printing is actually built into some of my 3D printers. So it will do AI error detection.
Mm.
So there's something in 3D printing that we call spaghetti. So if the printer misses or something goes wrong and the part gets pushed off the build plate and doesn't stick, and it just starts like printing in the air, so it creates all this loose filament, looks like spaghetti. There's a camera in the printer that will actually detect that, and it'll stop the print, and it'll say, "Hey, I think this has been a problem. I think you have some spaghetti. You should check it out."
Oh,
So
okay.
then I can go check it out either on the camera in my phone, or I'll go downstairs and check it out on the thing. And sometimes it's right, you know, and I'll stop the print. It saved me some material and some time. Sometimes it's, it missed it. It wasn't wrong, but it's still good just in case it was. So then I resume the print. That's where I use it the most for 3D printing. Other than that, I'm mostly just using it for like business and marketing and administrative side of things, but it hasn't breached into my workflow yet.
Okay. So far just for error detection, that kind of thing, but it's not really impacting your overall
No,
creativity or
not yet. I
workflow or
I could definitely see it
design.
within
Uh-huh.
maybe 5 years, getting more there, but there's still, I mean, text and understanding language is one thing. When it comes to 3D space, I'd say, I think even harder.
Mm-hmm. That makes sense. Now, looking ahead, what excites you most about where 3D printing is headed?
Yeah, like I said previously, I think it's still very much in its infancy, at least compared to the rest of the manufacturing market. Thus, doing pretty good with hardware in terms of the machines, but I think the software still has a lot to catch up.
Mm-hmm.
And, I'd like to see, I still feel like, I don't know if you remember, like years ago, maybe 20 years ago, where robotics was, uh, you know, you didn't really see too many robots walking around and doing stuff like you do from Boston Dynamic. They were very clunky and falling a lot. They didn't have enough sensors. They didn't know where they were in the world and what was going on. So I feel like we're kind of like that. That's where we are in 3D printing right now. It's, like I said, the printers are, to me, they're dumb. They're just following instructions without knowing what's actually going on. So I'm excited for the 3D printers to catch up to where we are with robots, and they actually understand what's going on.
Mm-hmm.
Like robots now can walk around, identify things, pick things up. They look not as clumsy, right?
Yeah.
I want 3D printers to have more sensors so it can actually make corrections in real time, change what it's doing in real time. There's just so much more there. So the printer's not just following instructions, but actually making informed decisions and changes in real time when it's printing. So you get an actual better part. It can catch more errors. There's all kinds of things that can improve with on that side of things.
Yeah. Huh. That will be interesting to see, yeah, how the technology evolves. Now, you've recently made the leap into running the niche 3D full time.
Yep.
What has surprised you most about entrepreneurship?
Yeah. I knew going into it. So like most of my customers have just found me through LinkedIn. So I got lucky. I got some really good customers, and I didn't really have to do any work for marketing or getting new customers until that's why I felt confident doing this full time. So I'm like, I already have a good customer base. What if I actually tried to acquire customers? I could build out the business and it would be, I could do this full time. So I knew going into it, marketing and getting customers and gaining an audience would be hard. But, I found it to be surprisingly, surprisingly very, very hard. Because I'm great, at least from my background, I'm great with working with customers, retaining customers, and creating great products. But in the front facing side of the business, that's something more new to me. It takes a lot of persistence to find new customers and get more eyes on the products you sell and the services. The other thing I've been finding surprisingly hard is the balance. I'm a solo entrepreneur, so I'm balancing all the admin stuff. I'm doing the accounting, the books, as well as engineering and testing and all the R&D backend and other stuff I want to do in the future. I'm always wearing a lot of hats at the companies I've worked at, but now I'm wearing even more hats and the roles are even more different than before.
Right. Yeah. So do you see yourself expanding and growing and bringing on other people to support you?
I would like to get to that point eventually. I'm trying to hit three different streams of income to not only sustain myself but sustain R&D here, and then hopefully be able to hire people. So I'd like to still want to do consulting. I'm selling filament right now, and then I eventually want to just sell my own products that I manufacture direct to consumer. And then I want to be able to fund, also hire people, but then use money from all those endeavors to pay myself, but also put money towards research and development
Mm-hmm.
to then take on developing more 3D printing technology in house and develop the technology more out like I have at my other jobs too.
Okay. So you're focused on keeping diverse streams of income. So you're not just depending on one or the other.
Yes.
And then, yeah, just growing that way, but then ultimately, expanding and bringing on more people to scale. For companies or individuals new to 3D printing, what's the smartest way to get started without feeling overwhelmed?
So it's it's easier than ever before to get into 3D printing. There's tons of YouTube videos out there. There's tons of different 3D printers on the market, which makes it great because it's easy to get into it. But like you said, it can be very, very overwhelming. What printer do I get? What technology? What material do I print? What are my applications? So it can be very, very overwhelming. But the material's there if you want to get into it. I would suggest if you have an idea for a product or part, or you need a solution, coming to someone like me and working with me more, either I can take you on as a client. I offer like 15-minute free like consultations so we can talk about different applications, or if you're interested in 3D printing, talking about it a little bit more for them to understand how to go into it and approach it. But like I said, if you have a part or an application, I think talking with someone like me, I can kind of narrow down what you should look into and suggest what to research and how to go about it. But if you just interested in the technology, not necessarily have a specific application in mind, I'd say the printers are so cheap now and there's so
Mm-hmm.
much resources out. Go buy a cheap Bamboo Lab A1 Mini. It's like $300 to $400. They're super easy to print with. You don't even need to know how to 3D model or slice. There's tons of available files online already that you can just press a button and it'll print, and that can get you started.
Right. But for anyone who's interested in creating more complicated parts or custom parts for their specific applications, I'm hearing just going to you or someone like you who already
Yeah, I
has
think it's
that skill set.
best to consult with some additive expert because they can narrow it down and either, like I said before, not everything should be 3D printed. So we could even say, hey,
Mm-hmm.
this actually isn't the best technology for it, or just narrow down the scope of the technology. There's so
Yeah.
many different 3D printing technologies and materials right now.
Yeah. I know that definitely makes sense. So for engineers, designers, or innovators listening, what mindset shift do they need to truly take advantage of additive manufacturing?
This is what I found with trying to sell the technology. People first need to have a problem that needs a solution, and then they have to be creative with how to solve it. And I know a lot of people in the industry right now, they know the traditional manufacturing. So that's how they think and go about it. And like, oh, you know, either some of these solutions are too expensive or we can't do it this way or that way, or this is the only way to do it. So, they kind of have like blinders on, but they don't know enough about 3D printing to know what it can do. Like I just had lunch with my neighbor the other day he doesn't do 3D printing. He's an electronics guy. But, he'll see the 3D printing online, see what some people are doing. And then I brought him in showed him some of the stuff I'm doing. He's like, "Oh, I didn't know you could do that." So there's still like tons of even people have 3D printed for years.
Right.
Sometimes some of the more hobbyist stuff, people are like doing completely crazy things that like people didn't even know you could do. I'm always like trying to push and innovate on what can be manufactured using 3D printing. So you need to have that solution that you need, but be creative and think not only maybe there's a 3D printing technology can do it, but also how to do it with the 3D printing technology. Because there's so many different ways to do it or experiment with to get a sometimes interesting solution. So
Hmm.
I think it's be more open, learn more about what 3D printing can do. Still understand some 3D printing definitely has its limitations, but don't feel so walled off by those limitations because you can really push a lot of these technologies to do more than what some people say they can do or what you think they might be able to do.
Yeah. And if nothing else, just, consult you or someone like you, right? Just
Hmm.
to get a better understanding of what those possibilities or limitations might be, just to explore, the options and opportunities. Because, like
The,
you said, the technology is developing so quickly that,
yeah,
yeah.
it's always changing. So
Uh huh. Yep.
it's hard to keep up with it if you're not actively in this industry and looking.
Yeah, that makes sense. Well, Matt, thank you for sharing your journey and helping
Thank you.
demystify what 3D printing can really do when it's applied thoughtfully. For listeners who want to learn more about niche 3D or your consulting work, where's the best place for them to connect with you?
Yeah, you can find me on my website at niche3d.io, also on LinkedIn. And if you're interested in learning more about 3D printing, I also have a podcast with my friend Alex. So you can find that on YouTube at Layered Insights Pod. We talk all different kinds about 3D printing. We sometimes have some show and tell, so you actually see some objects printed too. So yeah, I'd start there. There's also tons of other great people on YouTube to listen to and learn about 3D printing.
Okay, well, great. Yeah, so those listening today, please make sure to reach out and connect with Matt if you're interested or listen to his podcast. And the name of the podcast again was
Layered Insights.
Layered Insights. Yeah. And for our listeners, if you enjoyed this episode, be sure to subscribe and tune in to the next conversation. And until next time, stay bold, stay curious, and keep igniting industry.